VLPSos here. This is a video lesson for Python programming toggle movement. We're starting with a code file that we coded previously for hold movement. Let's run our code file to see what we did with hold movement. We have a simple screen with the square drawn. We can move the square around by pressing keys. The keys that have been implemented are W, A, S, and D. If I press A, then the square moves to the left. I have to hold down A to keep moving. When I release A, it stops moving to the left. I can also move down and to the right and up. I can move two directions at once by holding those keys down, and as soon as I release them, it stops. This is hold movement because we have to hold the key down in order to get the change. This is where we start. We're going to make a simple change to make this into a toggle movement style. Toggle movement means if I press and release the key, it'll move in the corresponding direction, and it'll keep on going until I press and release the key again. Toggle on, toggle off. Let's take a look at the code file and some parts of the code file that accomplish this. We have a class called object. We've made one instance of this class. That's the square that we move around. The square has an X position and a Y position attribute. The step attribute was for stepped movement, a different style of movement. When we press a key, it moves in the corresponding direction by a certain amount of pixels, just once per key press. If we want to continue to move, we have to continue to press the key. And it always moves a set increment. In this case, the attribute is equal to 10 for 10 pixels. The size attribute is the size of the square that's drawn. The speed attribute was used for our hold movement, and it will also be used for our toggle movement. 0.1, or the speed attribute, is used to move that amount of pixels, in this case 1/10 of a pixel per frame, times timing. We use time in order to get the movement proportional to our CPU speed, our frame rate. We have a number of booleans that we set an initial value for. Those booleans are very important in our algorithm for this movement, as we will review and look at. One instance was made of our object and put in the dictionary of things. In our frame loop, we have some commented out code for the now U objective that we'll get to in a minute. We also have an algorithm under the comment based on descriptive string value. This is for our stepped movement that we previously implemented. Our hold movement and what will become our toggle movement is controlled here. We use these booleans, the step left, right, up, and down. We use these booleans to determine if we are moving in a certain direction or not. If the boolean is true, then we change the corresponding position by the product of the speed, or the speed attribute, timing, and a sprint factor. The sprint factor was used to affect holding down the shift key in order to be able to move faster, and releasing it to move at a different rate. These booleans change their value based on key presses, and the key presses are detected in the event queue. Here is the top of the event queue. We have a code block on the condition of event type 2 or event type 768, which is the key down event type. So on the event type of key down, if the key is any of these values for A, D, S, and W, then we turn a boolean on or true. There are 4 booleans, one for each of the 4 directions. So if these booleans are true, it's going to affect that kind of movement. And the booleans are turned false to turn the movement off in another code block for the same corresponding keys, except that this code block is under the condition of an event type 3 or event type 769, which is key up. So here in our code, for those 4 keys, pressing the key down turns the Boolean true. Releasing the same key turns the Boolean false. And if the Boolean is true, you get the location attributes to change. We can make this into toggled movement quite easily. Toggled movement is going to be pressing the key turns the Boolean on, and it'll stay on even if the key is released, and then pressing the key again will turn it off. In other words, pressing the key changes the Boolean's value, true to false or false to true. We do not need to detect the key up events. We can get rid of that code block under the condition of it being a key up event type. And instead, just work with these Booleans or this code block for the key down type. And in this case, for each one of these Boolean variables, it's going to be equal to the opposite of what it was. We accomplish this by reassigning it to be not itself. Step left is equal to not step left. In other words, if step left was false, now it's going to be true, reassigned to be true. If it was true, it's going to be reassigned to be false, on and off, once per key press. I need to do this with each of these Booleans. And I can test the effect right away by running. I have my square. The Booleans are false to begin with. I'm going to press A, and I get a leftward motion. I'm going to press A again in order to stop. Toggle on, toggle off. D will move to the right. I'm not holding it down. I've got to press D again in order to get it to stop. I can move on an oblique by pressing 2 directions, in this case A and W, to the left and up, and I have to turn them both off. Down, then to the right, turning off down, and then turning off to the right. Toggled movement. We're going to code another effect, a pause. Pause is also going to be a toggle effect. Pause, and then pause by pressing the spacebar, and then turn off pausing by pressing the spacebar again. The stub already contained the event key number 32, which is the spacebar, and in the code block of event type 2 or 768, which is key down, we're going to create the Boolean pause, and we know that we want it to be a toggle, so it's going to be pause is equal to not pause. If I hadn't already initialized or declared the initial value of pause, then I need to do so before the frame loop. Set the initial value equal to false, so it's not paused when we first run our program. And of course, to get the effect of the program pausing, we want to think about what should happen when it's not paused. What should happen is we should be able to see motion happening. So in the place where we change our position in the frame loop, this block of code, we want to do this only on condition that pause is false. In other words, the program is not paused, so do the movement. And that's true for the other movement algorithm of taking a step. So this entire code block, and we'll get the comments as well, is going to be indented by pressing tab, and then the condition if pause is equal to false. I can run my program. In this case, I'm going to press A to go to the left, and I can press A again to get it to stop. but I can also pause. So I'm going to press D to go to the right and then press the space bar to observe that that's another way to get motion to stop, all the motion to stop. If I unpause, I can see that the motion is still happening, and then I toggle it off with D. This is a little confusing because motion can stop by toggling the motion off or pausing, and the user isn't really aware of what key got pressed to cause what effect. So very often, if pause is included in a program, we want a visual clue for the user to know that the program is paused, not simply that there is no motion. So we're going to add something to our code. In the frame loop, as a part of composing the screen, under the comment compose screen, which is near the bottom of the frame loop before we update and before we check our event queue, is the most appropriate place to put this kind of code. It's already been written, so I'm going to uncomment it. But take a look at what was previously added. On condition that pause is true, we're going to prepare a print line with the render function. So we're going to convert a string, in this case the string pause, into a graphic. That's what this line does. And then we're going to blit that graphic that we assigned to be the value of the variable print line. We're going to blit it to the screen. This math here used the screen center, a variable that was in the stub, and the get width and get height function with a little bit of math in order to center the rectangular print line graphic. So we ought to see pause drawn in the middle of the screen. We need to recall that if we're going to use the render function to create graphic text, then we needed to, before the frame loop, initialize our font setting. Let's take a look here for the reminder that the font setting needed to be prepared to use the render function on, which required choosing a font name and a font size or point, and putting those into the argument of the sysfont function. That's part of writing graphic text. Let's see if it's worked. Now I can move to the left or down. And if I press spacebar, the animation is stopped and the screen is showing me that it's paused. If I press the spacebar again, I unpause it and get the motion, but I can also toggle the motion off, of course, by pressing the direction key again. Now you. You have seen how to toggle a Boolean with a key press and have that Boolean affect continuous motion and pausing. Use this code file as a stub, which will contain the code for step movement affected by pressing the arrow keys. Make the step movement toggle as well, meaning make it continually take slow steps in the direction of the key press until the key is pressed again. Hint. Introduce a move Boolean variable that toggles every time an arrow key is pressed. Have move Boolean affect a time counter that counts down each frame by subtracting timing. Have movement affected only when this counter reaches 0 and resets. If the move Boolean is false, no countdown occurs, so no movement happens. This countdown is also necessary to stop step movement from happening every frame, which would be too fast for the eye to see. Much of the code to accomplish this objective is already included in this program, ready to be uncommented. That's a fairly sophisticated direction. I would encourage reading that text to get clear on what's being asked. But I'm going to show that some of the code for this has already been included. Uncommenting this code of text is on condition of the move Boolean true, which has been predefined already, then the move counter is going to reduce. We've seen this in a previous lesson, the concept of using an integer as a counter to count down. And once the counter counts down, then it causes something to happen. In this case, the Boolean take step will become true. Notice if take step is true, then we get the kind of motion which was stepped motion. So the counter is controlling this Boolean. We need a counter to count down based on real-world time so that that take step Boolean is not true all the time, but true only periodically, like once every 800 milliseconds. The code for taking step motion is already accomplished. The code for moving or for the counter counting down is already written in, it just needs to be uncommented. The Boolean move has already been included, ready to be uncommented. The counter and the counter set to control that timing has already been included there. The only thing that's necessary is to understand how that's working and add something or change something in the event queue to get all of this to work. Have fun.